Under what condition will the line y equals to mx plus c be tangent to the circle x minus a whole squared plus y minus b whole squared equals to r squared? Let us begin. So here we start with the given circle. We have the circle with the equation x minus a whole squared added to y minus b whole squared equals to the square of the radius. If we compare it with the standard form of a circle, which is given by x minus h whole squared plus y minus k whole squared equals to r squared, then here h comma k, this particular is the coordinate of the center of the circle. So that means this coordinate of the center of a given circle is going to be a comma b, and the radius is going to be equals to r. Fine. This is the circle that's given to us, and here we also have the equation of the line y equals to mx plus c, and we're going to express it in the standard form mx minus y plus c, where the standard form is given by ax plus by plus c equals to 0. Okay, the goal is to find out the condition under which this particular line mx minus y plus c equals to 0 is tangent to the circle x minus a whole squared plus y minus b whole squared equals to r squared. So let us begin. Now here we're going to use a property. Let's say we have a circle whose center has the coordinates h comma k. We have a straight line. Let's say the straight line is tangent to the circle at a particular point. This is touching the circle, and the equation of this line, let it be denoted by ax plus by plus c equals to 0. Now we know that if we draw a straight line from joining the center of the circle and the point of tangency, then this particular point this particular line CA is going to be perpendicular on the line segment, and the perpendicular length CA, that's the perpendicular length CA, that can be obtained by using the formula. We'll take the absolute value, and then inside the absolute value we'll consider the coefficient of x of the line. So that's a, this will get multiplied to the x coordinate of the center, so that's h, added to the coefficient of y of the line, so that's b, this will get multiplied to the y coordinate of the center of the circle, that's k, plus the constant term of the line, so that's c. This will be divided by the square root of a squared plus b squared. So we're going to use this particular concept here. So here we have the equation, we have the center, coordinate of the center, that's a comma b. We have the equation of the line, so that means the perpendicular distance is going to be, so let's find it out. The perpendicular distance is going to be, we'll take the absolute value. First we'll consider the coefficient of x of the line, so that's m. M will get multiplied to the x coordinate of the center of the circle, so that's a. This will be added to the coefficient of y of the line, so that's -1. This will get multiplied to the y coordinate of the center, so that's b, plus c divided by square root of m squared, that's the coefficient of x, added to square of the coefficient of y, 1 squared. Fine. And this is nothing, the perpendicular distance, if we go to a diagram, this perpendicular distance is nothing but the radius of the circle. And since the radius of the circle is r, so that means this perpendicular distance must be equals to the length r. Okay, the further simplification is going to give us ma minus b plus c divided by square root of 1 plus m squared equals to r. Now we'll get rid of the absolute value by squaring both sides. That gives us ma minus b plus c whole squared. The denominator, we get simply 1 plus m squared equals to r squared. So we have ma minus b plus c whole squared equals to r squared times 1 plus m squared. Let's do one thing. Let's expand ma minus b plus c. So here we're going to use the identity that if we have a plus b plus c, when we square it, then this will be equals to a squared plus b squared plus c squared plus 2 times ab plus 2 times bc plus 2 times ca. Now in a case here we have the second term that's negative, which means that our formula is actually a plus negative b plus c whole squared. So accordingly we can replace the value of b with negative b, so that means this term and this term is going to be negative. Okay, so let's apply So we get m squared a squared. So plus negative b squared, that will be simply positive b squared, plus c squared minus 2 times m a b. Then we have negative 2 times bc plus 2 times mac minus r squared m squared. So we've transposed the terms from the right hand side to the left hand side. This will be equals to 0. Now what we'll do, we'll take m squared a squared and combine it with r squared m squared. This will be one term. Then we have b squared plus c squared minus 2bc. So that's going to be another term. And then we will combine the remaining terms. So that's 2 times mac minus 2 times mab minus r squared equals to 0. Now from the first two terms, if we take m squared as the common factor, so that will get multiplied to a squared minus r squared. b squared plus c squared minus 2bc, that's nothing but the expansion of b minus c whole square, plus 2 times m times a, if we take as the common factor, then we have multiplied to c minus b, and we'll transpose negative r squared to the right hand side. So this is the required condition such that our line y equals to mx plus c will be tangent to the circle x minus a whole squared plus y minus b whole squared equals to r squared.